about oscillating motion and how it relates to energy and displacement for lab. Our goal is to measure the change in energy through oscillations, and specifically how we can satisfy the energy principle. So some of the calculations we're going to have to do are obviously with the kinetic, gravitational, potential, and spring energies, and also the change in energy, which should be zero, as energy cannot be created or destroyed. Additionally, for the spring potential energy, we will have to use the spring force formula and the period formula to calculate the spring constant here, which we did, and also the displacement, which is how much the string, or the rope in this case, is stretched or compressed. Calculations that we have to input into glow script. As you can see, we put in our constants here: the length of the spring constant, and the acceleration due to gravity. And then here is the spring force formula that we use to calculate some of the energy. And here are all the kinetic, gravitational potential, spring energy, and the total energy of the system, which is the mass in the rope. In addition to that, we need to input the initial conditions for the ball's mass, the position, and the velocity, and then all of these forces acting on it obviously cause the motion. And here we have to update the spring force for a small delta t, which you can see here. Some of the pre-lecture videos that there's already been a demonstration with this particular mass and the oscillation. This is just how the oscillation moves. Video posted as a pre-lecture video on the Canvas page, and how we can compute the y position, x position versus time on glow script. Our expectation should be that these graphs should look similar, as the forces are similar and the energy change is similar. So as you can see in the computational model, the x position versus time and the y position versus time look very similar and have similar shapes. And then we can also calculate the change in energy versus time, which we will talk about in this. It does mean the energy principle is satisfied, as you can see on this energy graph with the change in energy versus time. Delta K, delta potential gravitational energy, and delta spring energy all oscillate accordingly. However, they will always add up to be zero, and the delta E will always be zero throughout the duration of the motion.